In my last video, I was talking about uh, four components of problem solving: mathematical thinking, strategies of solving problems, and we have communication in mathematics and management of mathematical knowledge, right? And I was talking about there are three ways, in fact, in which we can think mathematically. One is through inductive reasoning, deductive reasoning, and analogic reasoning. Right now, but unfortunately, our students, especially Malaysian students, mostly works through deductive reasoning when they solve problems or when they learn mathematics. Like, for example, taking down several examples, and then doing problems, repeating, and trying to figure out patterns of questions in the examinations. That is the deductive reasoning. There is no thinking activities, there is no reflection, there is no metacognitive skills involved in the learning of mathematics, and they neglect these two parts. There is inductive reasoning and analogic reasoning. And analogic reasoning is very important, where students could be trained how to observe data, to see relationship between data, to see patterns, and to simplify data if they find problems too complicated for them to understand. They do simplification, like drawing diagram, representing through my map, and many other ways, right? But unfortunately, our students do not have such skills. Most of them, I would say most of them, over 98% of our students do not have these skills. This is not inborn, this has to be learned. And that's the reason why problem solving is a specialized field. It's a field where you solve problem solving. And there are PhD students in the field of problem solving. When I visited some of the American universities have problem solving as a course parallel to the mathematics program. This is to help students to view mathematics, or to help students to become efficient problem solvers, so that they can see problem critically and creatively. Right, now come back to just to show you one example of what is called analogy reasoning. For example, we have problem log 2 base 10 equals 0.3010. 10 to the power of 0.3010 equals 2. But through my experience, when I give these questions in the seminar, and I'll ask them, what is 10 to the power of log 2 base 10 equals 2? Many students find it difficult to answer this type of question, even though this is just basic questions in logarithm. Of course, as teachers, you may realize that one of the topics that students find difficult to understand is logarithm. Why? Because they used to study through rules, but they have no skills of applying analogic reasoning to the learning of logarithm and a few other topics in additional math. Right, now this is just one example. Not to say students couldn't answer this question. Many of them fail to answer this question. They fail to compare between 0.3010 and log 2 base 10, even though it was stated that log 2 base 10 equals 0.3010. When I change instead of 0.3010 to log 2 base 10, they have to pause, and some of them struggling to find the solution. Alright, let's forget about this. This is just to show an example of analogic reasoning. Now, how about showing another example on creativity? Let's say we have right. Suppose we questions asking students to find the area bounded by y equals to x cubed between -1 and +1. Alright, and I mean the curve lies between -1 and +1. You'll be surprised, some students will take 1 and -1 and then they will just integrate, and finally they got the answer 0, and they say, well done, I've done it well, and this is correct. Of course, arithmetically is correct, but not mathematically. How can the area equals to 0 in the first place? And that shows that not only they don't have the thinking skill to solve this problem, but also the common sense. And this involves two skills, other skills, and that comes under critical thinking. Critical thinking, two aspects of critical thinking is analysis, to be able to analyze problem, and evaluation, to be able to evaluate important information. For example, in real life situation, critical thinking is applied to analyze and evaluate claims, information, data, reasoning, argument, and so forth. In mathematics, critical thinking can be used to analyze problems, data, information. Now, here, if a student could say draw a representation of the curve, sketch curve of y equals to x cubed, and shade that part, that is analysis. He's able to analyze the problems, make the problem simpler, look simpler. That comes under inductive reasoning. Then that part of inductive reasoning is called simplification of data, and that in mathematical thinking we call it specializing, trying to make sense of the information. Right now, of course, they will go about solving the problem from -1 to 0 and 0 to 1. But of course there is modulus of those things. Now, where is the creativity? The creativity comes in. I was talking just about critical thinking. They analyze the problem, they draw it, make it simpler. They is using geometrical approach. And where is the creativity comes in? If a student is very creative, we will just take this part times by 2, or find the error of this part times by 2, because he knows that this curve is symmetrical about the origin. Now, or he will end up this way. This is a combination of knowledge about integration as well as thinking. Knowledge alone is not enough to solve complex problems, even in real life situations. But you need added value, that is thinking. That's the reason why problem solving is very important program, because it will help students to understand mathematics deeply, and that will help them not only to be creative, to be critical, but also to do better in mathematics. Of course, we used to teach students through drilling or through a deductive approach, less with the inductive approach. But that doesn't matter, and I can understand very well that teachers have to rush for syllabus, and there is no time for developing thinking skills. But it's my job, it's my part. I can play that part to complement what you have done in the class. You concentrate on the content approach. I will concentrate on the process-based approach. A combination of these two approaches will help students to understand math and become more efficient problem solvers. Just to take one more last example. This is also another difficulty when faced by this type of problem. You see, suppose they are as defined this area. Given this is R, and given this is the sector of the circle of a set is a sector, right? And this is the center of the semicircle. And if you ask the students to find the area of the shaded portion, it will it's quite hard for them, because especially without the skills of problem solving, without the strategies of solving problem based on Poyer's model, which I put it in part of the problem solving components just now. Like asking trying to understand problem, and trying in the understanding of problems, students may ask what is S, what are the given data, what are the important implicit information, how they do it, how they see the problems. If this diagram, how could they see the problem? If they can't solve the problem, perhaps they can draw the diagram bigger, or perhaps they can join 2 points to find ways to solve the problem. These are skills. These are skills that need to be learned. And of course, there are also creative approaches to solving problems. Training students to be creative will help them to be more flexible in solving more complex problems. And this needs, for example, one component of problem solving called strategies of solving problems. Communication in mathematics is like trying to develop skills so that they can express their ideas among peers. They can also develop skills in getting more information from the teachers. What do they prepare before they see the teachers? What they are supposed to do before they see they go and meet the teachers to get more information, to resolve their misunderstanding or misinterpretation. Now, how to manage mathematical knowledge? This is done to help them to organize their mathematical knowledge learned through their teachers. Of course, there are a lot of topics to be covered within 2 years, especially in additional math. Even then, not only in additional math, you find that in even simple mathematics like the one in standard 5, 4, 5, 6, 2, we find difficulties in answering questions involving figures, involving sentences. All this because they don't have the skills of problem solving. They don't have the skills of critical thinking and critical thinking in mathematics, or they don't have the skills of mathematical thinking. And two important components in mathematical thinking is critical thinking and creative thinking. So I would like if teachers or school authorities or heads of school perhaps could give them a chance and opportunity to let them acquire very important knowledge, not only in mathematics but also in real life situation. This is not just a relaxing session where people do mathematics just for fun, but it's an activity, it's an exposure, it is a knowledge that is very important for students to know if they want to become efficient problem solvers. Many research done on problem solving, and it was found that many students couldn't cope up with complex mathematics One important reason is that because they don't have problem solving skills. We have good students in boarding school scoring 8 A's, but it seems that there is no correlation, not very clear correlation between their 8 A's in PMR and their ability to do additional math in Form 4 and Form 5. So maybe we can arrange for them to have these programs exposed to them. I'm looking forward to see your students, and thank you for listening to my short talk. Thank you.